Next page is stoichiometry. I'm going to be using a piece of paper that looks like this. My patented 5-step process to do any stoichiometry is up here. These down here are just some specialized things that might be needed. For the first problem, I won't need those specialized ones. I'm just going to be using the patented 5-step process. Step 1 says write and balance the equation. It's already done for you. Step 2, we have to put a box around what I was given, what I want to know. I like to just isolate. What are we even trying to find out? I can find the given because there'll be a number. 785 grams of oxygen. Oxygen is going to be one of the important boxes in my BCA table. I don't need the whole BCA table. The other thing that they're asking about is grams of sulfur dioxide. Which one of these is sulfur dioxide? This one right here. We always start with 0 of this and 0 of this, but there's only 2 boxes I really care about. The amount of oxygen I start with and the amount of sulfur dioxide that I end with. These boxes are only for moles. So the next thing, let's see, we've done this, we've done this. The next thing I have to convert to moles if it's in grams. I have 785 grams of oxygen, but 785 grams of oxygen, 1 mole of oxygen, that's O2, that's 32 grams. 785 divided by 32, 24.5. 24.5 grams. Whoops, grams crossed out. Moles. That goes here. 24.5 moles. So I've written balanced, box around what I convert to moles. I set up my BCA. I filled in my start box. I now have to figure out the want box. This is my start because that's what they told me about. I want to know this stuff. How do I know what number to put in there? It's based on the mole ratio. If I'm going to make 2 of these, it's going to require 3 of these. You only get 2/3 as much. 24.5 moles times 2/3. Why 2? Because I want to know moles of SO2. But I was given moles of oxygen. 24.5 times 2 divided by 3, 2/3, equals 16.4. So the number that I'm trying to get to goes on top, that 2, that's 16.4 moles. You can make 16.4 moles of sulfur dioxide. Let's see. Now I've set up, figured out my one box even. Last step, convert to grams, because that's what it's asking. It doesn't ask me how many moles of sulfur dioxide, it asks me how many grams. So this equaled 16.4 moles of SO2. 1 mole of SO2 is 2 oxygens and a sulfur is 64 grams of SO2. .4 times 64, 1,049.6 grams. For the next one, which is percent yield, similar process. I'm still going to use the same 5-step process, only there's a little bit of extra info here to help me figure out what's going on and to actually turn it into a percent yield. I still start by writing and balancing the equation. Once again, that's already done for me. The next step is going to be to put a box around what I was given and what I want to know, trying to figure out what are they really asking on this. Let's see. They tell me that this stuff is used. That's one of the ingredients that I'm starting with. I've got extra oxygen, so that's not important. Now they tell me it's really going to form, actually going to form, it doesn't say actual, but it kind of, actually going to form 7.5 grams of sulfur trioxide. This must be one of the important things. So we're dealing with sulfur dioxide and then asking how much sulfur trioxide. Suppose I can move this down a little bit, 0 moles. So I have boxes around what I was wanting given. Next thing is to convert to moles if it's in grams. I'm starting out with 5.9 grams of SO2, but one mole of SO2 is 64 grams of SO2. That will cross off. 5.9 divided by 64 equals 0.092. 0.092. 0.092 moles. Okay, if I'm going to start with 0.092 moles, how many am I going to make? Well, 2 moles makes 2 moles. So 0.092 moles times 2 over 2, it's a 1-to-1 ratio, or a 2-to-2, also makes 0.092 moles. I've got a lot of steps that I just did. I converted to moles, I set up the BCA, I filled in the start box, I even figured out the want box. And now I have to turn it into grams, because that's how we measure stuff. How much does 0.092 moles of SO3 weigh? 1 mole of SO3 is 80 grams. It's 3 oxygens and a sulfur. 0.092 times 80 times 80, 7 point, when I round, 4 grams. 7.4 grams. Okay, so what that really means, when I get done doing some fancy BCA math, that's what that says. That's a theoretical amount. That number that I just produced, 7.4, that is my theoretical yield, 7.4 grams. What was my actual? That you just do by reading. It just tells you that it was 7.5 grams. 7.5 grams. And then what do I do? According to this, to get the percent yield, it's actual on top, divided by theoretical, times 100. The actual is 7.5 grams. Out of a possible of 7.4 grams, yeah, it's possible. We can get over 100. Equals 7.5 divided by 7.4 times 100 equals 101.4, or just 101% yield.